Have you ever looked up at the night sky and felt like you were witnessing something truly special? Well, get ready, because October 2025 is shaping up to be one for the history books. Normally, astronomers might spot 2 or 3 bright comets in an entire year. But in October 2025, something unprecedented is happening. 7 comets, including a visitor from another star system, are all set to make their closest approach to the Sun within a single 30-day window. Is this just a cosmic coincidence, a 1 in a million celestial lottery, or is something else going on? We're talking about a lineup that has astronomers buzzing. 6 comets from our own solar system, plus an interstellar traveler named 3IDTLAS, all converging at once. This isn't just unusual. It's a phenomenon never before seen in modern astronomical records. Today, we're going to dive into what makes this event so mind-bogglingly rare, what we can expect to see, and whether this incredible cosmic traffic jam hints at a deeper, unseen order in our solar system. To understand why this is such a big deal, we first need to understand what happens when a comet gets close to the Sun. Imagine a lonely frozen wanderer, a ball of ice and dust drifting through the cold, dark void. As it gets pulled closer and closer to our star, a dramatic transformation begins. This moment of closest approach is called perihelion, and it's where the real show starts. The Sun's intense heat warms the comet's surface, causing ice buried deep inside water, carbon dioxide, ammonia to instantly turn into gas. This process builds up immense pressure beneath the comet's crust. Eventually, the surface cracks, and powerful jets of gas and dust erupt into space. These jets don't just create a spectacular display. They can actually nudge the comets, slightly altering its path. Around the comet, a glowing cloud of gas and dust called a coma begins to form, which can swell to be tens of thousands of kilometers across. This coma is what makes the comet visible from Earth. Its brightness is measured on a scale called magnitude, where lower numbers mean a brighter object. To see a comet with your naked eye, it needs to reach a magnitude of about 6 or less. And then, of course, there are the tails. Comets typically have 2 of them. The dust tail is broad, curved, and yellowish-white, created by sunlight pushing tiny dust grains away. The ion tail is a sharper, bluer streak of gas pushed straight back by the solar wind. These tails always point away from the Sun, and their appearance gives us clues about what's happening at the comet's core. Every comet's journey past the Sun is a delicate dance. Some flare up brightly, only to break apart, while others survive to loop back into the darkness. This brief, fiery encounter is what astronomers study to predict which comets will become legends. So who are the stars of this upcoming celestial show? The story begins with Atlas, the asteroid terrestrial impact last alert system, perched on the dark slopes of Mauna Loa. Meanwhile, the Stereo spacecraft, which usually tracks solar storms, picked up 414P, a faint but fast-moving sun grazer that will skim the Sun's surface. And the discoveries kept coming. The Mount Lemmon survey in Arizona contributed C-2025A6, a periodic comet that's also expected to peak on October 21st. Its brightness is a wild card. Some models say it could reach a brilliant magnitude 3, while others are more conservative. Then, the Pan-STARRS survey in Hawaii added C-2025K1 to the list. While not expected to be a showstopper, its timing adds to this incredible cluster. But the most fascinating player in this cosmic drama is 3IATLAS. Spotted by the ATLAS survey in July 2025, its unique hyperbolic trajectory confirms it's an interstellar visitor, only the 3rd one ever confirmed. It will make its closest approach on October 29th, right after the main group. Its arrival turns an already rare event into something that has astronomers scratching their heads. For the first time ever, we have 7 distinct comets, tracked by different instruments all over the world and in space, all peaking within days of each other. This global network of telescopes has revealed a cosmic convergence that defies easy explanation. To put this in perspective, let's look at what a normal year looks like for comet watchers. For the last century, the rhythm has been pretty consistent. We get 2, maybe 3 comets bright enough to see with binoculars, and they're usually spread out across the year. Most years, we don't get a naked eye comet at all. When one does appear, it's a solo act, not part of an ensemble. Astronomers have gotten used to this slow, steady trickle of icy visitors. Records from the Minor Planet Center show that between 1900 and 2022, the average number of binocular visible comets per year was just over 2. Even with advanced all-sky surveys like Pan-STARRS and Atlas, which find fainter objects than ever before, that basic pattern has held true. A bright comet remains a rare and special event. Finding 2 bright comets in the same few weeks is legendary among stargazers. So the forecast for October 2025, with 7 comets peaking in under 30 days, is truly off the charts. Just how rare is this? Computer simulations that analyze a century's worth of comet data give us some staggering numbers. So what could be causing this? Is it pure, unadulterated chance, the wildest celestial jackpot in living memory? Or could there be something more at play? Some astronomers are starting to wonder if this clustering could be a clue. Perhaps an unseen gravitational influence, like a distant planet or a passing star, disturbed a dense region of the Oort cloud long ago, sending a wave of comets hurtling toward the inner solar system, all timed to arrive together. Another idea is that they could be fragments of a much larger parent body that broke apart centuries ago, and we're now seeing the pieces arrive. And then there's the interstellar visitor 3IATLAS. Its arrival at the exact same time is the biggest puzzle. Is its path through our solar system purely coincidental? Or does its timing hint at some larger galactic current that we are only just beginning to perceive? For now, we have more questions than answers. October 2025 presents a unique, real-time laboratory to study not just these individual comets, but the very nature of randomness and order in our cosmic neighborhood. The data we collect could rewrite our understanding of how the solar system works. Whatever the cause, one thing is certain: October 2025 will be an unforgettable month for anyone who loves the night sky. From the Americas to Europe and beyond, observers will have a chance to witness a celestial spectacle that has never been seen before. So mark your calendars, get your binoculars ready, and look up. You might just witness a discovery that changes astronomy forever. Have you ever looked up at the night sky and felt a sense of wonder? Well, get ready, because October 2025 is shaping up to be a month unlike any other in the history of astronomy. It's not just 1 or 2 comets gracing our skies, but a whole swarm of them, and scientists are trying to figure out why. This isn't some trick of new technology. From the moment astronomers started plotting the orbits of newly discovered comets in early 2025, a strange pattern emerged. Even amateur skygazers, using publicly available tools, could see it for themselves. A swarm of comets, all heading towards the sun, all set to peak in the same month. The sense of surprise was electric. Nobody could find anything like it in the history books. Now you might think, well, we have better telescopes now, so we're just finding more stuff. That's what astronomers call survey bias, and it's always the first suspect. But here's the thing: while we are finding more faint comets, the number of really bright ones, the kind you can see with the naked eye, hasn't changed that much. The 2025 cluster is a parade of major league comets, each one a standout on its own. Okay, what about the sun? The sun is heading into a period of peak activity, a solar maximum, in 2025. This can definitely stir things up, shaking loose some icy fragments and making comets brighter. But it can't just conjure up a whole fleet of massive comets from different parts of the solar system and have them all arrive at the same party at the same time. This clustering isn't just a quirk of how we're looking at the sky. It's a real physical event. So just how unlikely is this? Statisticians at the International Astronomical Union decided to find out. They used a powerful tool called a Monte Carlo simulation. Imagine a digital lottery, but instead of pulling numbers, they pulled random comet arrival dates from over a century of data. They ran this simulation 1,000,000 times, asking one simple question: how often do 6 bright comets, plus a visitor from another star system, all show up in a single month? The answer was astonishing: almost never. In 1,000,000 simulated years, this exact kind of cluster appeared only a handful of times. Let's be clear, this isn't a parade of faint, fuzzy blobs only visible through giant telescopes. These are bright, spectacular comets that would have been noticed in any era, with any technology. When you look back through the historical records, from old photographic plates to modern digital catalogs, you find solo acts, maybe a rare duet of comets, but never, ever a gathering like this. Visualizations from the Minor Planet Center paint a stark picture. For the last century, the calendar of comet arrivals is pretty sparse, with peaks scattered months or even years apart. 3 comets in 1 month is the stuff of legend. But 7? Including an interstellar object? It's a statistical spike so sharp it stands all by itself. No solar flare, no new telescope can explain this pattern away. The numbers are stacked, and they're telling us something extraordinary is happening. The models have spoken, and they leave us with a huge, hanging question. If this isn't random chance, what is it? Let's entertain a wild idea for a moment. What if these comets aren't just following the random laws of physics? What would it take to orchestrate their arrival? Dr. Kevin Blanchard, a member of the ATLAS Discovery team, crunched the numbers. To guide even 2 comets onto a synchronized path, let alone 7, you'd need a force far beyond anything we see in nature. Comets can be nudged off course by jets of gas and dust erupting from their surface as they heat up. But these nudges are tiny, changing a comet's speed by less than a meter per second over many months. To get these comets to all arrive in October, you'd need to change their speeds by tens of meters per second, 100 times more powerful than the most violent comet outburst ever recorded. If something artificial were shepherding these comets, it would have to leave fingerprints. We'd look for things like simultaneous outbursts of gas when there are no solar storms, or strange chemical signatures, metals, or molecules that don't belong on a comet. The biggest smoking gun would be an isotope ratio so unnatural it could only have been manufactured. But so far, the data is stubbornly ordinary. The comets are behaving exactly as we'd expect. Their spectra show the familiar fingerprints of water, ice, and dust. There are no engineered isotopes, no coordinated maneuvers, no secret signals. If a hidden hand is at work, it's hiding itself better than any technology we know. Naturally, the search for extraterrestrial intelligence, or SETI, has been listening closely. The Allen Telescope Array and the Breakthrough Listen project have pointed their dishes at every major object in the October cluster. They've scanned across a wide range of radio frequencies, listening for any engineered pulses or narrowband beacons. The result? Nothing but the natural hiss of the cosmos. This silence is just as telling as a signal would be. If there's a message, it's either hidden in a way we can't yet detect or it simply isn't there. Meanwhile, the sun is putting on its own show. The solar maximum is in full swing, blasting out coronal mass ejections and high-speed solar wind. We've seen comet tails disconnect and sudden bursts of brightness, but every single one of these events has lined up perfectly with a spike in solar activity. These are classic signs of solar-driven drama, not a coordinated message. And let's get one thing straight. There's absolutely no danger. None of these comets will come closer to Earth than about 25 million miles. The only real hazard during this time comes from the sun itself, which can disrupt power grids and satellites. As the comets get closer, astronomers are gearing up for a massive coordinated campaign. They'll be tracking every movement, scanning every spectrum, and sharing all their data openly. The old rule in science still stands. Extraordinary claims require extraordinary evidence. And right now, the evidence points to a natural, albeit baffling, phenomenon. So what could change the picture? A clear signal. A chemical that has no business being on a comet. A sudden, impossible change in direction. Until something like that happens, skepticism is our most important tool. But the fundamental mystery remains. No known natural mechanism can force unrelated comets from different corners of the solar system to converge with such precise timing. The 2025 comet cluster is a stunning reminder that our solar system is still full of surprises, a place where every new answer just seems to spark even more fascinating questions. We'll be watching, and we'll be sure to keep you updated. Thanks for joining us on this cosmic journey. If you enjoyed this and want to stay on top of the latest space discoveries, don't forget to like this video and subscribe to our channel. See you next time.